I would love to introduce our guest, Kiran Vodrahalli, a research scientist from Google DeepMind. A few months ago, Google released this report on Gemini 2.5. Kiran worked on some aspects of that report because the report covers and reasoning and multimodality and agentic capabilities, lots of cool stuff. Kiran, just to maybe set up the context of this conversation, maybe you could share about you, your background, and what specifically areas in that report you worked particularly, so we can steer the conversation to the areas that you're comfortable covering.
Thanks, and great to meet everyone. I'm Kiran Vodrahalli. I'm a research scientist at Google DeepMind and a core contributor on Gemini. My main research areas of focus these days are kind of long context reasoning, evaluation, and modeling. And also in the report in particular, I wrote the section on Gemini Plays Pokemon and the agentic analysis of the long horizon tasks and things like that, as well as some of the long context section. That's hopefully what we can focus on. And I think they are quite related as well. So it'll be kind of interesting to dive into the intersection.
Let's then discuss maybe start with the Pokemon game. Internet has lots of already walkthroughs and data there, and just wondering, do you know how many of those walkthroughs were already in pre-training data that model already has seen before you start training particularly on playing Pokemon?
So to set this up, what we were doing was we basically observed right around the time of the initial kind of release of the Gemini 2.5 Pro model in late March this year. There was somebody who was, just completely unaffiliated with Google, who was kind of streaming the game, the model playing the game. And we kind of noticed this very early on. It was very exciting to kind of watch them try to get the model to play the game. They were inspired by the Claude Plays Pokemon experiment, which had been a few months back and had gotten some interesting press. So it looked like a very nice opportunity to just try the model, without doing any kind of special training beforehand and see how well it could do at this kind of task. Kind of the experiment started without being pre-planned. Of course, after you've started the experiment, then the question you asked is extremely relevant. Well, how much of this performance is actually due to knowledge about the game from the pre-training data? Because you're totally right. In the pre-training data, it's going to be very difficult to go and scrub everything Pokemon related from the internet. It's a huge franchise. I don't know exactly, how much information is in the pre-training data, but it's extremely important to always keep this in mind when analyzing the performance of any model and on this kind of task. It's actually quite easy to get a sense of whether the model has high level knowledge about the game or not, because you can simply go to one of the hosted instances somewhere and ask it, right? And indeed, you'll find that for let's say Pokemon Blue, which is the game that the agent played in this case, it definitely has a ton of knowledge about the high level of the game. The other thing is that there's different levels of resolution. Maybe it knows the basic path for the game, you have to get these badges, then after you get the badges, you have to go to the Elite Four, and then you have to beat the Elite Four, and then that's how you beat the game, right? There's lots of details along the way, which may not be as well represented or at all sometimes in internet data. So there's definitely still a lot of challenges that the model has to solve. And the model also has to contend with hallucinations and issues like this, which actually can get exacerbated by pre-training data too. For instance, for Pokemon Red and Blue, there are remakes of those games as well. And those are also old games. And there are differences in those games compared to the original games. So if the model ends up relying on its pre-training data, in some cases, it can actually cause it to have wrong information. It's a very complex set of issues, I think. But yeah, 100% you have to pay attention to them.
It did have some data about Pokemon strategies and walkthroughs, but did you guys evaluate it? How before introducing different tooling? Did you evaluate how models Gemini 2.5 plays Pokemon after pre-training? Basically, without introduction of different tooling, right after pre-training, did you evaluate how it plays Pokemon?
No, not directly after just pre-training. We've only looked at the final model that has been released. So this is also because this is being kind of streamed and run by a third party to Google as well. We aren't like necessarily saying, okay, we have the pre-trained model and now we run some internal evaluation about exactly how much data it knows about Pokemon. Then I don't know if that would necessarily give you that much more insight actually than just like you can go to like, AI Studio right now and ping any of these models, and you can ask the different models, do you know what to do in this case in the Pokemon game? What would you do, right? And then you will immediately see the extent to which it can actually retrieve the information from its own internal knowledge or not. I would say that's like probably sufficient actually in order to understand how much the baseline model knows. The interesting thing to do, but I don't know if we're necessarily going to do this because it's quite, it's not like trivial to do this at all. You could try to scrub every single bit of information about Pokemon from the pre-training corpus, and then you could try to train that model. Then you could try to have that model go play the game. That would be an interesting but expensive experiment, and it would also be very difficult. It's very hard to kind of scrub everything about Pokemon, I think. It's just too pervasive. But there are other mitigations that you can take in order to try to measure the impact of that knowledge being already present. And so I guess I could mention a few of them. One of them, which we actually did, is you can try to tweak the prompt so that the behavior of the model, or the agent, I should say, is not so biased to trying to use its own information, right? So one way you can do this is you can say, oh, look, you're playing a game. It looks like Pokemon Blue, but you shouldn't assume anything about this game based on what you already know about Pokemon Blue. Things could be completely different. And like we call this like the noob prompt. Uh, Imagine you're playing completely like from scratch, right? And this actually kind of works in some ways. It actually has a beneficial effect and a negative effect. On the beneficial side, it helps with like hallucinations from like cross-generation stuff, which is not relevant in the game. And on the negative side, it makes it actually like waste time doing things it shouldn't do because it has to check things first and it has misunderstandings about things and so on. So that's one like kind of very hacky way to do it. And then to go beyond that, you can also start looking at games where it's literally not the same game, right? And there have been like substantial changes to the game that are different from whatever is going to be typically in the training distribution on the internet. That's another thing we did actually. It's
Can you please, can you please elaborate on that? Like, what other games did you try?
There have been so far like basically 3 official runs of Gemini Plays Pokemon. The first 2 were both Pokemon Blue, the vanilla game. The current one, which is currently ongoing actually, is for a game called Pokemon Yellow Legacy, which is a variant of Pokemon Yellow, which changes multiple things about the base game. One of these things is in Pokemon, there's this thing called the type chart, because different Pokemon have different types, like fire, water, grass, right? And there's like 15 of these types. Some types are good against other types and bad against other ones, right? So there's this whole like 15 by 15 chart, right, of what the effectiveness looks like. So this has been actually changed in this Pokemon Yellow Legacy. So that means that if you rely on knowledge that's like on the internet, and this Yellow Legacy is not like a super like well-known thing per se, right? It's not going to have that information in its training data, most likely. And there are many other changes that also alter aspects of the game. So the game is just made much harder as well. This is one way to like kind of mitigate against, okay, there's information in pre-training. Of course, it doesn't mitigate completely, but you can imagine, and we're planning to keep taking steps in this direction to remove more and more and more, get further away from the original game. And of course, the best thing is if it's a completely new game. So that's also hard.
But do you think like this kind of sort of contamination should be a concern? Because Pokemon is like very popular, right? And like if we are sort of trying to like bring this more agentic capabilities, like how we can understand, I'm trying to understand, like, should we like really worried about the fact that it's a popular game and that there already was existing data on this, and how to understand like the tooling that you introduce to make it play the Pokemon. I guess it's what is like Pathfinder, right? Like Boulder puzzle strategies, those long context tooling, that how they affect how the agent play Pokemon. What is the novelty here
Yeah.
in this particular case?
There's two questions you asked, and I think both are very important. What is it that you are trying to evaluate, right? So let's talk about the knowledge aspect. If you just have the knowledge of the high level steps of what you need to do to beat the game, can you actually beat the game with a model that we currently have? Well, it turns out that there's like many more complex sub-steps, and the rate of progress that at which you'll make within a fixed given harness. We'll talk about the tooling in a bit because it's quite important. You can't really compare across harnesses. And what I mean by a harness is the set of tools that it has access to, basically. And you can't compare across them, and each harness is going to help you measure something different, right? And the same thing I would say is also true of the knowledge aspect. For instance, like we ran this kind of experiment on not just 2.5 Pro, but we also had the same harness on Gemini 2.5 Flash. And so it's exactly the same harness and very similar kind of like knowledge, right, in the data. And you can observe on this evaluation, the rate at which it progresses through milestones is extremely different. It's like much slower for Flash, actually. I think this is like kind of a testament to the fact that what we're measuring here is to a large extent also the model's ability to like solve puzzles and navigation. And there's also like battle logic. It has to basically manage all of these different things together at any given point in the game to make a decision about what is the correct next step. If you're interested in measuring that kind of low-level application of reasoning and the ability to kind of understand what's going on from the existing context, I'm not that concerned about the knowledge element here. This is like already very hard, actually. When we started the experiment, I didn't even expect the model to finish the game. I was surprised that it was able to, because there's a few challenges along the way which are just like, even if you kind of know like the high level of the game, it's not at all clear that you can actually implement that into the low level sequence of actions that you need to input, right?
It finished the game even without introduction of this tooling, of long context tooling.
So I'll get to the tooling in a bit. That's a separate kind of question related to the knowledge. I can go into that now, actually. Yeah.
No,
So,
hold on. I didn't want to interrupt. I just wanted to
no.
I'm following your thought. The model was able to finish the game. I'm
Yeah.
just wondering, was it before it had access to tooling or after?
So it is
Let's
completed.
understand the state of the model, like the capabilities of the model.
Yeah. So it has completed the game under, let's say, roughly 3 different harnesses. And maybe what I can describe is what does each of these harnesses actually measure? And then that'll give you a sense of, what is the impact of the tooling and why is that relevant and why is that not relevant? A harness, right? What is a harness? So, okay, if you want to play the game, you A, have to have the environment of the game. And then B, you can consider like, building like an agentic scaffold that you put the model into, and then it drives the game, right? So those are 2 different parts of the thing. One thing that I want to like kind of highlight as a caveat before going into any more details is that if you just feed the game image at any given point of time to the model, it will not be able to play the game that well. That's because the level of resolution of understanding of like these kind of, I think they're a bit more out of distribution images, is not sufficient to get past certain roadblocks. Or it's like it kind of leaves it to chance in some sense. So that's what happened with Claude Plays Pokemon. Claude Plays Pokemon like doesn't necessarily have it has a bit less information about the game state in its inputs, but in such a way that it becomes very difficult for it to do things like identify a certain like pixel, like a cut tree. So there's these trees that you have to cut in order to make progress in the game. And if you can't find this like one little cut tree and recognize it, then you can't like apply the move to get past it, right? So that's like, it's this kind of roadblock that ended up coming a lot in Claude. And I think the philosophy for Gemini Plays Pokemon was a bit like, okay, we're interested in understanding like the vision, understanding vision is very interesting too, right? Don't get me wrong. But we were kind of having a different angle here. Like the goal was kind of, can we measure the ability of the model, do like long context reasoning and actually get through the game that way, right? So from that perspective, the vision component wasn't quite as interesting. So it's like, okay, let's remove that part of the problem, turn it into like the RAM state or whatever. Let's see what we can do from there. That caveat out of the way, you could imagine many different kinds of like sets of tooling. Over the course of the first run, the tooling was actually modified just to kind of see like what stuff works, what's the like kind of the minimal thing we can try to get to so that it actually beats the game. So the first run was a pass where the tooling was being changed over the course of the run. The second run, we ran with a single fixed set of tooling, didn't change it at all to see how it does, right? The second run was much faster. It was like twice as fast as the first run. And this tooling was basically, it had a few important things. Okay, one thing is a fog of war map. Okay, so that means that whenever the player character explores a new area, it's all blank, but as the character explores more, it gets revealed more. And then that whole map gets like, saved, right? So whenever the character returns to the area, it'll have kept its progress. So that's kind of a proxy for memory. This is very important, I think. Otherwise, if you don't have this information, it's kind of difficult for the model to even apply any kind of tools to like navigation or things like that. So that's number one. Number two, there were two particular tools. One was the Pathfinder tool. The Pathfinder tool is just a call to another Gemini 2.5 Pro agent, just without the same huge amount of context, only some of the context, and with a specific prompt saying, hey, you're a Pathfinder. Mentally simulate, some approach to pathfinding that you pick and, reason it out about what sequence of steps you should take to get to whatever location you want to get to. Okay, that's all that tool is. And then the final other tool was this boulder puzzle solver tool. And this was a bit more specific because there's a puzzle in the game at the end of the game, which requires you to push around these boulders in a dungeon onto switches in order to unlock things. This tool was very similar to the Pathfinder tool in that, again, it's just another agentic prompt to another instance of Gemini 2.5 Pro saying, hey, there are these boulder puzzles in the game. These are the physics of how the boulders work. Reason through yourself and figure out how to push them around in order. So those are the two tools, and then the fog of war map. And then the other critical thing for the first two runs was also the introduction of something in the prompt that was like explore at all costs kind of prompt. Like your number one priority, if you haven't explored things, is to explore. So these things in combination made it possible to like get through the navigation parts of the game much more quickly than previously. Now, I will say something else. In the third run, we actually removed these things. And actually, what we have instead is a tool that allows the agent to build its own tools. So it could create these tools itself. And in fact, it did.
And what did it create?
So it actually has created like many things. So one of them is a Super Pathfinder, which handles both of those problems. It has created multiple different kinds of battle agents. It has created team building agents. It has created debugging agents because we also gave it the ability to write code in the new run too. So it would make a tool, run into a bug, and then it would get frustrated that it kept running into the bug. So then it makes a tool to say, okay, help me debug it, which is kind of funny. There's many other tools, and the other thing is that only like 10 tools are allowed at a time, or 10 agents are allowed at a time. So sometimes it deletes things and it brings them back again kind of over the course of the game. The main takeaway from why these tools are important is not that it's like, you shouldn't think of it as, oh, it's because a human intervened and figured out what kind of tools were needed. That's not the main thing here, because the model can do that as well. The main thing is that you're kind of separating out the context that's more irrelevant, and you're making the model focus on a smaller set of context, and that helps improve the capability.
The tools that you introduced, did you measure how it was performing after you introduced those tools?
In the run one, this was done in a very ad hoc kind of way, right? More of a qualitative sort of approach. It would become very apparent whether or not like this tool was useful. Okay, so the first time the Pathfinder got introduced, when did it get introduced? After a certain puzzle. It's called Rocket Hideout. In Rocket Hideout, there are these like spinner puzzles. It looks like, there's a bunch of these like squares with arrows. And if you step on an arrow, you spin in that direction until you hit a stop point or until you hit another spinner, which maybe points you in a different direction, right? So it's like a maze, but with these like automated spinner things that you have to figure out in order how to get through, right? So the model, the agent, I should say, was, it was making progress through these puzzles, but very slowly. The idea was like, okay, if we introduce this Pathfinder agent, we want to really just kind of focus all of the reasoning and thinking power on just this thing. Will that help it solve the puzzles faster, right? So after it was introduced, there was this puzzle it's been stuck on for 5 days or something, right? In the version without. After it was introduced, it solved it instantly, one shot. It was very obvious immediately that it's super important and useful to do this kind of context management. Yeah.
I'm actually intrigued about the tools that agent, like the model created.
Yeah.
Did you also like evaluate how it plays the game with its own tooling versus the tools that you introduced to it?
I guess we have only run this self-improvement style harness on the Yellow Legacy game. It has not been run on the Pokemon Blue yet. I think it's a very interesting thing that we should probably do and check as well. My guess is that, so actually, like, I guess we can sort of compare since some of the parts of these games are like very similar, almost identical, especially for some of the navigation things. For those specific parts of the game, like this rocket hideout thing I mentioned, the model built tools are actually, just as good. There's no problem. The main thing that causes slowdowns is the model may decide sometimes that the tool is bugged when it isn't.
It's like sort of hallucination or something, or what is it?
Yeah, it's kind of hallucination. It's kind of like it's more like it makes an assumption if something doesn't go exactly as it expected. It expects, okay, I entered my coordinates into the tool, and the tool like didn't get me exactly where I wanted to immediately. And sometimes maybe that's because it's not possible, right? There was a flawed assumption when inputting the coordinates, right? But then, oh, it didn't get me where I wanted to. That means the tool is broken. I gotta fix my stupid tool. And then it spends like too much time like trying to fix it when it wasn't broken in the first place, right? That's an extra added complication, but often like when it has the tool and it has created it and it's not broken, it does like, just as well as whatever human created tools. This wasn't super surprising to me because the tools, like the prompts, were actually in the run one and run two, like with a bit of human intervention, mostly created by Gemini itself anyways. It wasn't a huge leap to assume that it can probably do it itself. That said, I guess there have been some instances where the tool actually was broken and it did need a fix, but it tends to be more that the model thinks it needs to be fixed and it doesn't.
What is the difference between introduce tooling on post-training, giving model access to tooling,
Yeah.
versus allowing it to create tools itself?
Yeah, there's two different capabilities here we're talking. One is the ability to actually use the tool, which means identify when to use it, input into the tool correctly and parse the output correctly, right? And then
Yeah.
the other aspect is like, what tools do I need, right? Which is a different question. I think both are very interesting and very important. The first one has probably been more standard for a longer period of time, right? Everyone kind of, knows tool use is an important thing. And many models, support this. Improving the ability to do tool use, yeah, so if you have data, training on that data is usually helpful, right? So certainly, various approaches that go along that route are generally going to be helpful at actually using the tools. I think the more ambiguous question is how do you bake the ability into the model to actually figure out what tools it needs. That's a more challenging task, right? And that's also like going to be kind of dependent on awareness of the environment that it's in and so on.
It's still work in progress.
Yeah, definitely.
Work in progress. Okay. Can we maybe discuss like technical challenges that you encountered during the training, and how do you think about, mitigating those challenges? Like something like that really surprised you, like those, I don't know, something that was unexpected. I guess some things you expect, some things might was not expected. I don't know if it
Yeah.
was the case.
Yeah, there wasn't any specific training for the agentic stuff, but there were many observed challenges and many, observed problems and things for future work. So many of them. So let me think about, let's see, what are some of them? So one thing actually is, I guess it's been brought up already by some of the questions, right? The question of the harness. If you have a different harness compared to like, let's say some other model, it's currently, quite difficult to like do any kind of reasonable comparison. People can have like some intuitions like, oh yeah, this harness is kind of similar to this other harness, but it's not really comparable in a lot of ways because it turns out that even the slightest changes can have a huge impact on the way the model behaves. I mentioned this noob prompt before, right? For run two, where we said like, you're completely new to the game and don't assume anything about the game based on your knowledge. So this actually costs around 100 hours in run two because the model had a misunderstanding about what a certain item did. So there's this final set of challenges at the end of the game where it has to fight 5 trainers in a row, right? And it can use its healing items and so on. Well, it misunderstood what a full heal is compared to a full restore. And if you're not familiar with the game, you would think, okay, what is the difference? These sound like the same thing, right? But one of them heals all of your full health, right? And the other one only heals like this thing called a status condition. The agent thought that the full heal was the same as the full restore, and so it kept buying full heals. And then since that agentic setup didn't have any way for the model to learn from its mistakes, like it didn't have a notepad, it didn't have anything. It kind of looped and it kept doing this full heal buying thing, which was completely useless in order to help it get through the Elite Four. So that ended up adding like around 100 hours. And that's just a very small change in the prompt. How do you compare across harnesses? It's very challenging. How do you understand what a given harness is measuring? That also needs more looking into. I think we have some decent sense for these ones we constructed for Gemini Plays Pokemon, but there's a lot more to explore here. The way I think about it is different harnesses kind of like different microscopes into the model's capabilities, and you can design them in different ways to highlight different aspects, right? So the harnesses we were looking at were more focused on I guess like long context reasoning and tool use. This new harness that we've been looking at is more focused on self-improvement and can the model actually learn from like zero shot in a sense, right? So that's one thing. And then in terms of the actual like agentic capability, one thing is also on the long context side, actually. So I had mentioned that one of the other things I did in the report is like kind of like long context evaluation related things. So that's a very particular interest of mine. How do you measure the ability of the model to do well at long context? And what does that even mean? One distinction that I like to make is between retrieval capability and reasoning capability. So when I say retrieval capability for long context, I mean like you have a huge context and maybe there's some needle in there and you need to retrieve the needle from the haystack. It's that kind of flavor. When I say reasoning, I'm referring to more like, oh, there's multiple pieces of relevant information in the context, and you don't necessarily know what all those relevant pieces of information are in advance. It may not be immediately obvious. It may not be like signposted, but you need to nevertheless find those relevant pieces of information and synthesize them to get your answer. And so a lot of the time, what you're doing in this agentic long context Pokemon setup is the agent itself is generating the context, right? It's kind of on policy in some sense. What happens is that it needs to be able to recognize, oh, I tried this, I tried this, I tried this. Those didn't work, so I need to try something new. And that's, I would call more like long context reasoning. But what sometimes happens, especially as the context length gets larger, is it defaults more into retrieval mode. And by that I mean it loops. It finds some action it did in the past, and then it kind of, next token predicts it. And then it loops and it loops and it loops and it loops and does the same thing over and over again. And this problem gets worse as the context length gets larger. What we kind of like observed is that it's kind of like 100K context is around like the sweet spot for this particular model setup and this particular harness. But we want to be able to push that much, much, much larger as well. That's the other thing also. It's kind of nice. We can also kind of predict that from some of the long context evaluations that we have. So in the report, we have these two evaluations. One is the Loft benchmark, which is a challenging retrieval task, where basically you're given a bunch of documents, each with a document ID, and the model is given a question and has to say, oh, these were the relevant documents to answer that question. And then the other task we have for long context reasoning is this multi-round coreference resolution task, or MRCR. And that's actually like a fairly simple reasoning task. It's actually hard for the model. And that task is you basically have a dialogue between like a user and an assistant. And it's things like, write me a poem about penguins in an archaic style. And there's many different variants of topic, format, and style. And what you do is you have like 8 of the same request in there. And then you ask for the model to reproduce the ith instance, right? So like the 4th instance of a poem about penguins in an archaic style, right? And if you look at the kind of the plot of performance as a function of total context length, you'll see this drops, right? It drops better than some of the other models, maybe, but it still drops quite significantly. I would say around the 100K, 120K mark is for this like particularly challenging version of the task is where you really see the performance start to drop. For the more retrieval-like tasks, Like the loft one, that's maybe a bit further out. That's more like 500K, 1 million. The point is that the task matters quite a bit when you're looking at long context. And I think in this agentic setup, the task can be quite complicated, especially for the context that gets self-generated by the agent. So that's one thing. You want to have both of these capabilities, and you want to push the ability of the model to do long reasoning over larger and larger contexts. So that's a very important thing here. Okay, hallucination, of course, is a broader problem. Vision, of course, vision is quite good on many things. On this particular distribution, it isn't as good. I don't know if that's like the number one priority necessarily, but it would be nice to have even more general vision that actually applies to these very old Game Boy type screens. That would be very interesting. I think I alluded to this, right? But the fact that the model creates its own context means that it's easy to also poison the context with incorrect things, right? So you need mechanisms to detoxify the context as well, right?
Can you please elaborate when you say like it? What exactly poisons? Is it because it's looping or something else?
Looping can be one instance. There can be things where it comes to a conclusion incorrectly, and then that conclusion persists for a long time until it realizes, oh, that was the incorrect conclusion. So this is something that's been helpful with this self-improvement harness, where it can actually test and hypothesize and realize that it made mistakes and fix them.
It's capable of doing it.
Yes. It has done this, yes. Yeah, it's actually very interesting. Like you can see in the notepad, so in the link in the slides, on the 10th slide, if you look at the notepad on the GitHub, you'll see the edit history over time for that as well. And you will see it in many cases realize, oh, I made a mistake. That was not correct. I came to the wrong conclusion. Cross it off. This is my new hypothesis. Let me test my new hypothesis.
Any human intervention.
That's right.
Okay. Okay.
Yeah. Well, I guess the only human intervention here is that in the prompt it says something like, you have a very scientific mindset and you like to do hypothesis testing or something like that, something very minimal like that. Other than that, no, it's not any human intervention. Yeah. It's now this may take a long time, so that's another thing, right? Like efficiency. It sometimes can take a very long time to realize that it's wrong, right? Which is, less ideal. And the longer that the stuff is poisoning the context, also the worse the performance will be for that period of time, right? So it has a compounding effect. More methodology to, improve this, right, is definitely an interesting and important thing. There's also some kind of like idiosyncratic behaviors that we observed in the earlier runs that were quite interesting. One of them is well, I guess we call it like agent panic. So sometimes the model gets into bad situations, right? Like, oh, all of its Pokemon are almost fainted or something, right? Means that it's about to lose. And in these situations, it's like kind of qualitatively apparent that the reasoning performance of the model gets worse.
Oh,
It's kind of
okay.
funny. Yeah. It's like, I think it's because it's like kind of like it knows it's in a bad situation and it knows that as a character in a bad situation, it should be panicking about it, right? So then it dedicates more tokens to be like, oh my God, I'm doing so badly. Oh no, everything's going wrong. And then it's like actively starts making bad decisions. It's like kind of very funny. So that's you could view that as also a kind of misalignment, I suppose, if you want, where you don't necessarily want the model to do that, but it's like, trying to be true to like what it has observed, I guess, in training, right? Like maybe there's lots of text where it's like, oh man, I messed up. And then
I'm wondering like about like long context. I
yeah.
don't know if you can cover. If you can't, that's fine. Like, do you have at least ideas? Like you said, like the sweet spot is 100,000 tokens. Do you have like ideas like how to push forward this long context to make it bigger so it can the looping like increases like the
Oh, I will say definitely many, many ideas. Also, when we say the sweet spot here, yeah, this is specifically for this like trade-off in this agentic setup. Depending on your task, it could be that 1 million is your sweet spot. Depending on your task, it could be even that less than 100K is your sweet spot, right? So it's going to be very task dependent. But the main thing is to be able to push on all of these much longer. And yeah, there are many research ideas, many things being looked into and implemented, as we speak. So I can't comment on what those things are, but for sure, yeah.
We'll look out on announcements from
Yeah,
DeepMind.
exactly.
Okay.
So just like general question overall, would you say it's like safe to conclude that if Gemini is able to solve this game itself, that you can give it any task, like in corporate world, create an Excel or anything you can think of? Is it like a good proxy that could solve it, that it could solve any other task?
Basically, the question is about generalization, right? Like, okay, like it
Yes.
plays Pokemon, awesome. Like how we can generalize this on other tasks.
I wouldn't make a huge leap. I think this is a nice demonstration that, okay, so why Pokemon, right? What's interesting about Pokemon? The thing that's interesting about Pokemon is that it's a simple-ish world where there are many different components that have to come together for the model to be able to solve the game. It has to solve puzzles. Some of these puzzles are actually like, non-trivially complex. They require like some level of reasoning over, a lot of information. And keep in mind also that when we're giving the model the representation of the game, it looks much more complex than the way it looks to humans. Because what we have is like we have like it's partially like text-based, right? So you have this huge map represented in text, and you have all this extra like information, and it has to be able to process all of that information and make progress, right? So that's actually like, that's like I would say it's kind of a sweet spot for the model capabilities these days in many respects, depending on what kind of harness you're looking at. Like you can trivialize some aspects of this if you change the harness, right? For sure. But the way we were doing it, we were trying to kind of keep it so it's like more at the sweet spot. So that's one challenge. Another challenge is you have to like actually like do this team building exercise where you have to like get different Pokemon, you have to train them, you have to make sure they know the right moves so that they can progress through the map. You have to find like hidden items in order to progress through the game. You have to manage money to some extent. It has many like elements of a more realistic and broader environment, but it's still a simple environment, right? This is a game that was designed for like, kids, right? So you don't want to make too huge of a leap when looking at this, but certainly it's like an interesting milestone. It convinced me at least, right? Like I did not think it would be able to beat the game when we started this. I thought, okay, maybe it'll get to like the midpoint of the game or something, and then it'll get like hard stuck by like there's this area called the Safari Zone, right? Which is kind of like it's almost like a timed sort of setting, right? But it was able to actually do it with the setup that we had.
I'm wondering, did you observe any like reward hacking during the game?
I have an example that's not quite reward hacking because is what should have happened, but it's kind of similar to reward hacking in that you wouldn't have expected it to do this, and it kind of found like an edge case. So I'll describe what happened. Basically, there's this part of the game called Cycling Road where you get on a bicycle. In this cycling road, it's like downhill. So you're forced to constantly move down. And the only way you can avoid being constantly moved down is you have to like continuously press up. Okay. So like a human can do that easily, right? They just continuously press up. But in the harness that we had, there is no ability. The model cannot do that. Like, period. It's impossible to do that. There happen to be two squares on Cycling Road where if you end up there, the only way out is to press up continuously. The agent found itself in one of these squares. So it got trapped. Okay. In many instances, this would have been a game over. But what happened actually is that it found out a way out of there because it has a Pokemon that knew the move Fly. Okay. So after like 4 hours of like trying different things that all failed, right? It tried many times to like go up and out, but it can't. It physically can't. And then I tried some other strategies, and those were all blocked. And eventually, it was actually able to figure out that it had to fly out. And this was very interesting to me because this is 100% not in any training data because this is an impossible situation to be in, usually. It's not quite reward hacking, but it's like it has what this tells me is that it would not be surprising if it would be able to come up with some kind of reward hacking situation. The other thing, actually, now that I think of it, that's even more reward hacking like is it adopted this like whiteout strategy. It would be in the game, it would be trying to get through a cave. It would be like, oh, I can't get through the cave. I need to try again. Oh, but I can't get back out of the cave. So, okay, I'm going to faint all my Pokemon so I get put to the last Pokemon Center, and that'll get me out of the cave. So that's kind of more reward hacking in flavor. Let me see. Was there something else? Another thing that's also kind of related, I guess. Nah, it's not really reward hacking, but
Still share.
oh, still sure. Okay, sure. Like another thing that is observed is like there's many instances where there's like appears to be a solution to a problem that's like kind of nearby. The model gets greedy and tries to like kind of take that option that's nearby. But actually the true solution is like much more circuitous. Often takes a long time for it to figure that out. I guess that's not really reward hacking.
I mean, it's still interesting. Actually, the first example that you gave is not reward hacking, it's just hacking. Like
It's just hacking, it's just hacking,
on
exactly.
the way to
Yeah.
like continue the game. I think it's like super impressive.
Yeah, it's not reward hacking, but it's hacking, and that makes me think that reward hacking is definitely plausible.
Yeah. I'm also wondering, based on this, this like work, what we can tell about the latest capabilities for self-improvement.
This is like more hot off the presses style thing. So I want to like reserve some of my thoughts on this, but I think it's like quite impressive that it was able to design its own harness. I think that's quite cool. Anyone interested, I recommend you take a look at some of the logs. The logs are super entertaining, honestly.
It's on GitHub, right?
On GitHub. This is the GitHub of the Gemini Plays Pokemon dev, Joel Zhang. And basically the model is what's committing here, not the dev himself. It's the model.
Anything else you wanted to share? I think in an email you mentioned about long context evaluation. I don't know if we covered it enough. Like, is there like any final thoughts, something that you feel like talking about work that you did and like maybe we didn't cover enough that you want to mention?
Oh yeah, I think we mostly covered it. Yeah, basically, yeah, it's the main thing about long context evaluation. You want to distinguish between what kind of task and what kind of capability you're looking at, like, and whether or not it generalizes over a longer context. So in this like Pokemon evaluation, right, the tension became between this retrieval and this reasoning looping behavior. And that, well, I guess the point emphasized here is that it was kind of nice that the context length at which this kind of like became really detrimental was kind of predicted by the simpler evaluations. I think there's still plenty of work to be done in the long context evaluation space. There's a lot of more synthetic tasks, right? Like this MRCR task I mentioned, it's completely synthetic and it's very simple as well. There's a lot of work to continue to do to make more realistic long context evaluations that have a broad coverage over capability as well. Yeah, if you're curious about that kind of thing, I guess there's also a link to this paper that I had that introduced the MRCR task that talks a lot more about other aspects of long context evaluation. But yeah, I think we covered most of it, the main relevance here.